Proszę Państwa, zaczynamy od prezentacji Johna Newtona. John Newton to osoba, która jest, no nie zawaham się tego użyć, legendą obszaru digitalizacji, od dziesięcioleci związany z budowaniem przedsięwzięć biznesowych, informatycznych, technologicznych, współtwórca i współzałożyciel Alfresco, wizjoner, osoba, która aktywnie uczestniczy w pracy stowarzyszeń branżowych, osoba, która aktywnie uczestniczy w pracy nad standardami rynkowymi. John opowie Państwu o aspektach digitalizacji przedsiębiorstw w kontekście aplikowania technologii. John, welcome.
Good morning, everyone. I've actually just come in from San Francisco. I heard all the names of all the cities, and I've been to practically every single one of those Alfresco days around the world. So starting off, well, last week I was in Boston, San Francisco, and now Warsaw, and then I go back home to London. I actually live in the UK, and part of the origins of Alfresco was to figure out what are some of the business models that actually work in Europe. And as you could hear, most of our business is actually in Europe. Well, anyway, yes, we will have great conversations. Oh, okay. That's kind of backwards. This must be a left-handed clicker. Here we go, all right. Or I'm holding it upside down. Okay, yeah, so what I'd like to talk about today is about how some of the new technologies are going to affect our particular space and how they're going to affect digital transformation. I'm not going to present anything really about Alfresco, more about the technologies that I think will impact where things go from here. So, and that has been my job for a very long time. It feels like over 500 years ago, but it was really 25 years ago, I was the founder of a company called Documentum. And this is the original team at Documentum. 27 years ago. It was in March of 1991. And if you do have Twitter, who has Twitter here? And I guess the rest of you do not follow the President of the United States and know. I would actually recommend, don't look. But my job has been to look forward and see how these technologies are going to affect how we manage information, how we manage documents, how we manage websites, but also business processes, and how do we digitize our businesses more effectively. In fact, during this time frame right here, we were going through a digital transformation for Boeing aircraft. We were building some of the first software that would be managing what had been a paper-based manual system for Boeing and turning it entirely to a digital system. Now, just about a year ago, less than a year ago, Boeing has now replaced that system with Alfresco, and they're actually one of our largest customers. Now, do you recognize these people? Do you recognize any of them? That's Rex Tillerson. He was the Secretary of State of the United States. And there's, this is the Justice Department. This is Sean Spicer, who used to be the press secretary. These are the cabinet officials in the White House, okay? And there's constantly changing. So we see the lights flickering here a little bit. Now, what if the same thing happened in the White House? How many people, how many cabinet members would it take to replace a light bulb in the White House? The answer is 1, because only he can fix the light bulb. Anyway, that joke works in English perfectly. This is a guy who thinks he could do everything himself. Actually, perhaps the answer should be 0. Can you imagine a robot coming in here and changing all the light bulbs in this room? Well, we haven't gotten to the point of artificial intelligence quite at that point, because as you can see, there's some glitches that need to be worked out in some of these systems here. Now, I'm going to ask you, this is robotics. And there's some artificial intelligence in there. But in terms of next generation artificial intelligence, how much artificial intelligence was there in that robot? The answer is 0. It's entirely a mechanical feedback system. So you're trying to take mechanics and apply it to the problem of robotics. But the future of robotics, the future of artificial intelligence, is actually software, and it's learning. And that will be the foundation of a lot of things that are happening in computer science and in digital transformation. So in thinking about artificial intelligence, Merton talked about 3 of the things that are foundations of our strategy. One is design thinking. The other is open thinking and using open source, open standards, open architecture, open data, open APIs. But the other one was platform thinking, to look at the problems that we're solving and look at them from a perspective of a platform. Now, McKinsey is a global strategy consultant. They go into your company, you pay them a lot of money, and they will tell you, how can you proceed forward in the future? Well, I'm going to save you a little bit of money. When they talk about digital transformation, they actually talk about it from the perspective of platforms. And if you have a solid company, a company that's been around for a while, you actually have a lot of advantages over a startup in that you've got a platform that allows you to have information systems, to have perhaps a global scale. You have all your compliance and governance policies in place and procedures. You have your IT infrastructure, security, and authorization. Now, if you were to open that up by providing open data interfaces, open APIs, open standards, and open architectures, basically make IT systems access all the capabilities of your corporation, then what you can do is you can start to build digital initiatives to deploy those capabilities in your corporation as fast as a startup. So take your advantages of your capabilities, add APIs to them, add open interfaces to them, and then you can start to build applications, initiatives, to be able to address some of the needs and concerns of your customers, your employees, and your suppliers. And the way that McKinsey asks you to think about it is, well, first of all, how many people have an iPhone in the room here? Okay. How many people have an Android? Okay. And how many people have a Windows phone? Nokia? Xiaomi? Okay. Actually, that's a higher percentage of Android phones that one of the highest I've seen so far. Last time when I presented this in New York, and I think it was about 95% of the people had iPhones, which I think is interesting. You go to San Francisco, you'll see more Androids because, hey, Google's based there. So is Apple. Anyway, so it's a bit like the, sorry, I lost my train of thought there. It's a bit like these phones, which is the phone evolves relatively slowly. It's a platform that you can rely on, but you have lots of apps on these phones, And those apps are constantly changing. You're constantly downloading new apps, you're replacing existing apps. There's a lot of agility in terms of what apps you put on there and how you use them. But the platform remains the same. And this is your opportunity to use your stability of your platform to create a stable platform and then have a very agile set of tools to be able to take and address your digital transformation. What they say is that agility rhymes with stability. Now, when you use a platform, it's a very, very powerful tool. We look at all the different companies that are up here. These are the most valuable companies in the world right now by market capitalization. They don't necessarily have the biggest revenue, but they are the most valuable. And what makes them so valuable? Well, look at the ones that are in bold right here. These are companies that I think you can call platform companies, that what they do is they have open interfaces to be able to connect many different types of applications, many different people in the ecosystem, many different companies. And it is the sense of the power of their business model. And they're looking at a platform not as a technology, but as a new way of looking at their business. In fact, when you look up digital transformation on, in Google, or if you choose, you can use Bing. When you look for what is the digital transformation strategy of these companies, all of them are looking at creating a platform. Even companies like Johnson & Johnson, connecting directly with patients and customers through a digital platform. Berkshire Hathaway is actually the firm that is run by Warren Buffett. People know who Warren Buffett is, one of the most, probably one of the richest men in the whole world. Well, he has a holding company. It's very, very small. It doesn't have a digital transformation strategy. But the people on Berkshire Hathaway's board are digital experts, because he takes those people, puts them into all the different companies that he owns, or that Berkshire Hathaway owns, and helps them go through digital transformation. Now, there's only one company on here which is European. Can you see it? It's the one in italics, number 17. Nestle is the only one in the top 20 that's European. Why is that? Well, when you look at platform thinking, the Europeans are, and I'll say we Europeans because I live in Europe. I've lived in Europe for 23 years now, actually 25 if you count the time before. You just do not see platform companies out there. It's not part of the thinking. But it's your way of actually getting competitive advantage when you think about your capabilities as a platform. Now, these platforms are also going to be the way that new technology is introduced and the way that you engage with customers. And most of the way you think about this is cloud first. Not cloud only, not all in on cloud, but it's actually the fastest way to start to deploy these platforms. And then you start to build your digital business platform out of core services that access all the resources in your company, including people. Now, we happen to think that some of the core services that are really important are going to be content, governance, process, and then insight and analytics and intelligence on top of those different areas. And those aren't the only ones. Communication is another area. E-commerce is another capability. And really, this is not our digital business process, but your digital business process, pulling together those services, including basically going in the direction of providing a microservice architecture, APIs, security, and things like that. But these are the platforms that allow you to go off and do that. And then having the ability to build applications quickly. And you'll see some examples of this in Martin's presentation a little bit later. But all the components, language, continuous integration, and then you can start to build the customer digital applications, the partner digital applications. But in this platform, we can see many use cases that actually aren't a whole lot different than when we started Documentum way back when. In the last 25 years, I would take all the applications I've seen and kind of group them into 4 main areas. One is individual productivity, to be able to take information, store it effectively for things like authoring and discovery, research. Group collaboration in terms of creating proposals, selling, marketing, publishing, to automate processes, whether it's contracts, compliance, claims, services, and then integrating into other applications to be an archive or record store of that information, or to feed information to those processes, such as capture, archival, integrating with systems like SAP or Salesforce. But there's problems out there that go beyond that. We can't just look at the world from the same lens as 25 years ago. So this is an example from one of our customers. The customer is called FINRA, which stands for Financial Regulatory Authority. They're the people who look at the banks and try to find fraud. You know, who's manipulating the market? Who has been missold products? So when people complain in the US, they're the ones who pick up the complaints and handle it. So the banks actually report directly into FINRA. And they are looking at trillions of transactions every single day and dealing with millions of complaints, even billions of pieces of paper every year. And it's simply too big to handle the old-fashioned way. They actually, because they have to deal with so many transactions, especially certain times of the year, like the end of the year, there's huge number of trades, and yet they still have to find market manipulation. So they're, Amazon's, one of their top 3 largest customers in the world. They have something like 25,000 servers. Now, where do you go out and buy 25,000 servers? You know, this is on any particular day, they'll be able be pulling that much up. Also, how do you deal with this much information? How do you classify all this information without people? How do you take and read all this and summarize it so people know what's inside of it? How do you know if this contains personally identifiable information, such as, you know, national security number or national identity numbers or patient information? How do you extract information of entities and resolve it to the items inside of your other enterprise systems? And how do you find related information which will help you resolve this? Well, really, the only way to do this is with software. You can't do it with people because there aren't enough people in the world to be able to solve this. And that's where some of these disruptive technologies come in. And these are the technologies that I think will have an impact to be able to solve some of these problems of quickly building digital applications, and also to be able to handle the huge volumes of information which are growing exponentially. If you want to know how this industry is moving forward, just look at the pace of how much storage there is in the world, which continues to grow exponentially every single year. Well, you need artificial intelligence to be able to deal with these. You need new architectures that allow you to assemble new systems and replace the components which become obsolete as quickly as possible, and reform new architectures as needed to be able to address new requirements. I think there's a clear role for the cloud, which has gone beyond infrastructure as a service, to become actually a new way of thinking about computer science. Also, the introduction of blockchain. How many people here have heard of blockchain? Basically everybody. And is that because of Bitcoin? Maybe that's usually what people look at and think, hey, maybe I can get rich too. Well, there's far more to it than that. Also, the Internet of Things, computing at the edge, and then taking all these bits together and creating new ways of interacting with users in what I call multimodal user interfaces. So let's start with artificial intelligence. What is it and what's different now? So I have been looking at artificial intelligence since I was 16 years old. In fact, I am a huge fan of Star Trek. And I know that eventually you would be able to talk to computers. You know, that was the way things were going to go forward. And unfortunately, it didn't happen quite as fast as I had hoped for. My intention was to go to Berkeley in California, to go to university and start to build robots that I could talk to. That was an overly ambitious goal. And then halfway through, I decided, no, I'm going to go into database technology, which ended up being a smart financial decision, but didn't allow me to work on something that I've always wanted to work on. And back in those days, it's something that is now known as GOFAI, G-O-F-A-I, good old-fashioned artificial intelligence. You have a bunch of rules, and then stuff comes in, data comes in, and that will trigger some actions, and you just chain all these rules together, and then you'll get intelligence. That was a deeply flawed assumption of where artificial intelligence was going to go. But it served a purpose. Rules are still the foundation of most of the automation in the world. Then there was version 2, which came out roughly in the 1980s. And this is the first level of machine learning. It was relatively simple. You put in training data, and you get actions out. And usually, this was a very fast system. It was based upon statistics. I put in a bunch of data, something comes out, and if it's not right, we have a feedback loop that will adjust the formulas as to when data comes in, what should the action that comes out. That worked until relatively recently, up until about 2011, 2012. That was the most efficient and effective way of applying artificial intelligence. And that required going from coders to mathematicians, statisticians. And now we're in a completely different world. We're in a different world that has been enabled by cloud and assembling lots and lots of computers together rather than having single machines do something very specialized. We now have general purpose learning machines that link all the different systems together. And what you now have are feature engineers who are trying to pick out features out of documents, out of images, out of video, out of sensors, and try to understand what are the actions, what are the outputs that are trying to come out. With a lot of self-tuning systems. In fact, you have artificial intelligence running artificial intelligence to be able to tune those new models. So this is very model-driven and learning-driven. And we're going from a world that was very code-based to a world that is ultimately becoming more model-based, where models are going to be more important than even code in the future. And all this stuff is moving very, very fast. I mean, so fast that whatever presentation I put up here and new capabilities that are absolutely amazing are going to be superseded in 3 months. So I gave a presentation in November. By February, it was obsolete because of new developments in this area. One is because of the internet, we can collect so much more information than we were able to before. We have new large data sets, a lot of it collected by governments, a lot of it collected by some of the largest companies in the world now, and making it available so that you can learn from this data. Open source is probably one of the most powerful drivers in the whole thing. So those of you with iPhones, do you have Siri turned on? I can't imagine how good it is in Polish. It's not very good in English, and it often gets things wrong. And when it came out, it was so cool. You know, it's like, hey, I can talk to my phone, and it talks back to me. And yet, it wasn't that good. And the reason was Apple liked to keep everything closed, but Amazon and Google took an entirely different approach, which is making it open source. And then the academic community started picking up on the open source stuff. And now anything that is AI that is progressing at a super fast pace is out there because it's an environment where you can collaborate. So that's been a big driver of this innovation. I mentioned cloud allowed us to be able to assemble huge numbers of machines, and actually machines that we wouldn't necessarily buy. Now, there's a processor other than the CPU on this computer called a GPU, which is a graphics processing unit that is making it possible for the computer to present this picture on the screen and have everything appear instantaneously and scale properly. It turns out that's exactly the type of mathematics that is perfect for those machine learning tools. And so using exactly the same processors as what drives your display is actually driving new artificial intelligence. In fact, sometimes increasing the power 1,000 times in terms of what you're capable of doing. You can now also buy huge racks of these things on a cloud vendor to be able to build these artificial intelligences where you wouldn't be able to afford that on premise. You can also crowdsource. And you can use Crowdflower or something else as well, but I can take that data set that is required to learn and train it by sending it out to people in Africa, in India, in China, for pennies to be able to train. And so using the internet to have humans train the systems is also having a profound effect. Then there are machines playing against machines. Human beings can only train a computer so fast, but when you have two computers kind of playing against each other, they can train each other even faster. So we're actually getting to the point of more and more unsupervised training of these computers. And then finally, taking all these capabilities and making it so any of you can actually go out and start to build artificial intelligence. Now, you're probably thinking, why would I want to build an artificial intelligence? You know, I'm not an AI expert, but really, there's so many domains that really don't belong to computer scientists. I mean, programmers are really good at a lot of things, but they're not very good at things like social science, economics, chemistry, and those are the models that have to be trained in the future. So these are opening up with new platforms and new tools that make it super easy to be able to take and train it. And you don't need to know all the background of the mathematics, the coding, the statistics, and whatever to make these things run. You just want to train a model. You want to give it data and show what is the right thing. And so all these things are going to mean that perhaps a lot of the stuff that I've told you today and will be telling you is going to be obsolete a year from now. But it's going in the same general direction that more and more systems can be automated. As an example, how long do you think it'll be before an AI passes a university entrance exam? So, what's the most prestigious university in Poland? Any answers? I don't know. What is it?
Let's say Warsaw University.
Warsaw University. Okay, sounds good. How long will it be before they do that? Well, in Japan, Tokyo asked that same question. Number one university in Japan is Tokyo University. And so Tokyo University said, someone there said, I wonder if it's possible that we can write an artificial intelligence that can pass our own entrance exam. And so they actually built a robot filling in a form, a standardized form, to take the entrance exam at the university. You know, actually writing it out and whatever. And in that entrance exam, they were answering questions like, what was the 15th century maritime policy of Japan? And it was actually writing essays that were better than the essays that a lot of the students who took the exam were taking. It was taking questions in mathematics, in Japanese, in English, because English was part of the entrance exam. And so they did all this stuff. And in the end, this project failed. It did not pass the entrance exam because it's a very hard university to get into. But what it did do is it did better than 2/3 of the entrants who tried to get into Tokyo University. That's amazing. And on top of that, the results that it did were enough to get it into many universities in Japan, just not the very best. That's where we are right now. Now, can you take that and solve any problem with this? No. This was very tuned toward solving this particular problem, but it shows how close we're getting. It means that a lot of knowledge work, and that represents knowledge work, those exams, will be replaced by computers. Is that a good thing or is it a bad thing? And I'll speculate that toward the end here. Now, in order to be able to take these new capabilities, we need to be able to take and plug it into our architectures. And that's where microservices are actually playing an important role. So we have things like content repositories, process engines, analytics engines, and stuff like that, all hooked together. And the way that we've assembled these things together tends to be, traditionally, a monolith. You know, I package up a whole system into one big package and then deploy it. And if I want to add something else, I'm going to have to create a new monolith and then figure out how it all fits together. Well, that's not a very agile architecture. And so we've been architecting our system toward a microservice architecture. In fact, a lot of companies, I would say financial services are the ones that are leading in this particular area. And instead of having just API to API calls where everything's synchronous, a lot more of it is asynchronous with a message bus. Now, well, let me just see how technical this audience is. How many people here in this audience program ever? Okay, all right. Good thing I threw in that ever, right? Makes you feel good. And I'm in the ever category myself, okay? All right. How many have never programmed a computer? Okay. So that gives me good sense. Now, I'm going to ask this question, and I'm going to realize that some people won't even understand what I'm asking, let alone the fact if you speak English, you won't understand what I'm asking. But how many of your companies are working on somewhere in the organization a microservice architecture? That's kind of like about 1/3, okay. All right, well, this is a big transformation that's happening in the world of building computer architectures, software architectures overall. And it's actually being driven by the cloud primarily, to be independent of any underlying platform and how we deploy it. Anyway, we've got a lot of different components that we want to constantly replace, we want to scale independently, and we want to evolve independently, and we want to also add things like artificial intelligence, blockchain, and things like that. Well, an architecture that is more message-driven as opposed to API-driven will allow us to be able to take and scale this thing out and make for a far more loosely coupled architecture where components are hooked together. And there's two technologies that are having huge impact in terms of new systems. It's Docker and Kubernetes. These are two technologies that have won. Docker is just a small company, an independent company, but they have now containerized systems. So think of containers as like the next generation of virtual machines. And then Kubernetes is a way of actually orchestrating and scaling it up. So we can start to build these microservice architectures in such a way that they can scale infinitely. We can make infinitely big, and they can be distributed across the entire planet. So this is a profound impact, a change in terms of how we architect systems. And then where this runs is on top of the operating systems. Now, I'm choosing Amazon for a reason, but it's true for Azure, it's true for Google Cloud Platform as well, is that there's no way to even have a diagram of what the cloud looks like. You know, a puffy white symbol is not a very helpful analog anymore for what we're building here. But if you look at just all the different services that are available, and this is a high-level view of things that are available. It's things like, it's not just compute, it's not just storage, it's also databases, analytics, networking, integration to many, many different types of systems. It's also the ability to manage all this, to secure it, to provide identity, even providing that machine learning, that deep learning capability, being able to work with media, having developer tools, at your ready, to hook into mobile devices and Internet of Things. All this is just kind of there. Now, you could choose, because you want absolute control over everything, to deploy all this stuff on premise. But when you have this much capability, why not take advantage of it? Now, how do you do it in such a way that it's independent of the cloud provider? Well, that's where the microservice architecture comes in. You isolate it, you abstract it using the microservice architecture. But where you can take advantage of it, you should take advantage of it, because something that would take you years to get to could potentially just take you days, even hours sometimes, to get to that ultimate solution. Now, the thing that is kind of coming in from left field in terms of the technologies that affect our area is blockchain. Now, George Peripadakis, who's going to be speaking later today, he and I was a member of, I guess I'm still a member of AIM. George is a member of AIM. And we were at something called the Executive Leadership Council, talking about new technologies that are going to affect things. And I chose to choose a discussion group on artificial intelligence, and I got nice attendance. A lot of people are interested in it. But more people seem to be interested in this one. And I don't know if it has to do with Bitcoin or not, but it does have to do with, there's a new way of storing information, a new way of collaborating with other companies around the world. What a blockchain is has nothing to do with cryptocurrencies and stuff like that. It's a distributed, encrypted ledger. It can be either public or private. But what's powerful about it is you can write something onto the public blockchain, and only the people that you choose to allow to see it can actually see it. But it's like a distributed database that when people write to it, from not just inside your company, but from many, many different types of companies, there's this distributed consensus-based algorithms that make sure that when you write it, only one thing can be written and there's like one transaction that actually makes sense. So there's no double entries on this thing. So it tends to be a really good basis for audit trails that are distributed between companies or even inside companies. And it's also a way of delivering things from one organization to another, one person to another. So basically, data can go in there, documents can go in there, code can go in there to be executed, and there's ways of having secure code in this environment. And based upon the data and the code, you can have things called smart contracts, which automatically kind of update themselves. And you can even put value inside of there, which is where cryptocurrencies come in. So I'm not one to invest in Bitcoin or any of the new coins that are coming out here, but the banks are betting that there's going to be crypto euros, crypto dollars, crypto yen, and all the major currencies around the world where you can exchange value from one organization to another. Why is that so big? Because you can do it without a bank. You'll be able to transfer from one to the other. You'll be able to exchange securities without an exchange. And that's really, really disruptive to the entire global economy. And that's why people are so interested in it. And this fits in so much into the type of things that we store in content stores and how we manage process. That this is the basis for processes that go from one organization to another, to kind of chain off and link processes together, and to be able to connect these together. So this will be the basis for collaboration of the future between companies and a way of storing information. In fact, storing in ways that will persist beyond even the life of an individual company. Okay, and you take all these things together, you know, the artificial intelligence, the new ways of scaling up, the ability to understand what's being said, the connection. I didn't really have time to talk about the Internet of Things, but new devices that you'll be able to talk to beyond even watches and stuff like that. And basically, there's going to be new ways of interacting with people. Now, the way that PCs started, where there's a screen, a keyboard, a mouse, is still the primary paradigm in which we interact with computers, with the possible exception of touch interfaces, where I can have, instead of a mouse, I can actually touch where I want to go. But it's going way beyond that in terms of voice recognition, chatbots, and even recognizing gestures. So next to my laptop, or even on my phone, it will very soon understand what am I looking at. And that's kind of clear from Apple's research, that they're trying to understand where are you looking and what gestures are you doing with your eyes. There's little micro radars that will understand even delicate movements of your fingers or general waves. In fact, there was just a patent that Amazon filed that when a drone comes, that it would understand, no, don't land, or thumbs up, yeah, go ahead and land my crate of beer here. We're very thirsty, so these gestures are going to be important. And in fact, even facial and eye gestures, understanding all these things together will mean that the conversation between the computer and ourselves is going to be more intimate, more human-like. They're not humans, but they'll understand what are we trying to, that nonverbal communication, that's part of how we communicate one-to-one. It will understand that. In fact, maybe even be able to feed that back to you to provide a more empathetic way of working with this. And so when we think about an application framework, you're going to see the state of the art a little bit later here in terms of how you build applications. But even that, it's going to take the next step in terms of really, intelligent access of what am I looking at? What is it that the computer's seeing? What are we seeing together? How are we communicating with it? And all this will be part of the application development environment that goes way beyond what we see today. And this will allow entirely new digital capabilities that weren't possible before. So new ways of inputting based upon natural language understanding, image recognition, voice recognition, automation beyond rules to be things like auto-classification, auto-translation, auto-summarization, being able to perform actions, based upon speaking and communicating, decision support, making recommendations, and new ways of analyzing. They go way beyond just, here's a chart, actually understanding what does that chart mean? What does it mean for the information that's in there? Detecting anomalies and security threats. And then even the infrastructure itself. This was one of those changes that I was very surprised about. I mentioned I didn't do AI, I did databases. And there's these things in databases, the indexes called B-trees. B-trees have been tuned over decades to be super efficient. But it turned out that there was a project that looked at using deep learning and artificial intelligence to store things that was actually faster and created an even smaller database than a human-tuned algorithm that's been tuned over decades. And I thought, wow, you know, things like database indexing, full-text indexing, everything we knew about databases will be obsolete themselves. In fact, how we store things is going to be driven by artificial intelligence. So all this stuff is just entirely new use cases that we think about, and you know, in terms of what we can do with this capability. So changing that individual productivity to go beyond the mechanics of, yeah, I can fill in a form, but why should I? Maybe it should be more about creative support and proactive research, very fast and easy self-service and content generation. New types of group collaboration where there's ambient intelligence in the background that will be adjusting the views to the group, having more intelligent meetings and more intelligent coordination of getting things done, and essentially eliminating the tedium of work. New process automation of smart contracts and traceable value chains and automated tasks and self-organizing processes, and new ways of application integration of using voice and gesture capture rather than just image capture and scanning, having a complete value chain visibility and blockchain archival between different companies and stuff. And you look at all these different things and you see that there's a huge potential. And will it replace a lot of human work? Well, yeah, it is. And that's why people are starting to talk about the minimum guaranteed income. But also, it's coming probably at just the right time. Our productivity as a nation, well, as a global, as the global economy is not increasing. And part of that is because the populations are becoming much older. One of the most eminent economists said, perhaps this is coming at just the right time, that as the population gets older, instead of bringing in new workers from outside, perhaps we just become more efficient through this artificial intelligence and automation. So we just see that, you know, all the innovation that's coming is just coming at such a rapid pace. So here's another example which just came up. And I think what's interesting is that when you look at where the artificial intelligence patents are coming from, you expect it to come from the United States, but actually there's more coming from China than there is the United States. And it's just coming so fast, so furious, but they're handling some problems. Like there's a test in the United States called the Stanford Standard Reading Test. And computers can now read, understand, comprehend, and answer the questions in the standardized test better than human beings can. There's like a 97% accuracy when it answers and asks the questions. And we're just coming to this really radical change in terms of what the capabilities of computers are. And if we apply it properly, there's going to be huge benefits from it. If you don't use it, well, you're just going to be surpassed by those who do. So I think it's worth looking at these technologies, figuring out how it features into your digital transformation. These are far-looking, they're a little bit ahead, but it's something that you will need to pay attention to in the future. So I hope that gave you kind of my perspective in terms of where things are going. These are going to be the drivers for where Alfresco is going in the future. It's not enough to say, yeah, we're the ones that are architected in this century rather than the last century, but this is not a field that stops, and you got to keep ahead of it. That's up to us, and it's also up to you as well. Thank you very much.